everyone see the full-on version here? Excellent. Okay. Um, so again, thanks for a small group currently. We wanted to get everyone together to talk a little mass timber. I think it was a topic that maybe we had hit maybe last year, Greg, or something, but we hadn't done anything on it this year. And I think we did some work on EPD, some work in concrete, some LCA stuff, and some, tally and some of those things, but we hadn't talked about mass timber. And I got this idea sort of in a national CLF kind of leaders type call. Somebody was like, well, sometimes we just do forums and just get smart people on there and just have them go and get a lot of audience participation and have questions and that sort of thing. So the point of this, I think, was to do that. If those more people come in, trickle in, we could just get some questions rolling. But as just a quick intro, that I feel like I probably don't have to do for most of the folks on this call, but just in case, we always give sort of the same couple of very basic slides that are kind of deemed easy and appropriate by CLF National. But we have our operational carbon sort of keeping the lights on, which is a strong concern. I work at it every day. Energy modeling, lighting, et cetera, et cetera. What we concentrate on here is more the embodied carbon, so all the materials of the building, the manufacture, transport, installation of those materials, and comparisons about what to build with, how to build, member sizes, all kinds of things. Interior sort of runs the gamut that we talk about on the embodied carbon. I made this slide years ago, but I always come back to it and just sort of the carbon story of a building. Again, I think that's clear for most of us here, but we have our sort of operational energy use over time, but it's sort of the blips in red that we kind of look at of CO2 output. There are more issues as well. We have the eutrophication and on, the things that we get from our EPDs and our LCAs, but obviously we're looking at the embodied carbon here. So the CO2 bumps up and then it goes to this sort of higher total, and includes some bumping up in end of life, which would be very interesting to talk about when it comes to mass timber. Maybe something that we can cover as a team. So high impact categories, just threw these in. These are kind of the standard materials from Architecture 2030. They're probably better slides, but we often talk about steel, some of those carbon impacts in structural building. Things like insulation can be high impact. And then obviously in red, the concrete that we know and love. I do put a question mark on purpose for high impact categories because we're obviously doing things in concrete and steel and insulation across the board, and everything that we put into buildings that are making it better. But that said, obviously concrete and cement as a part of that, we know is a huge emitter. And I think that mass timber is doing a good job of replacing, specifically some output from concrete. So bringing that one in. Impacts of wood, obviously there are some. There's CO2 output for some of the things that are done in the manufacturing, milling process, et cetera. Obviously transportation. I do find this one interesting because we do have sort of the stored CO2 arrow that sort of comes back as if we sort of have at least somewhat of a cyclical trail of the CO2, although that also gets into some of the biogenic carbon and end of life stuff, which we can also certainly talk about. But overall, I think it's pretty obvious that mass timber is if done correctly, which is sort of a topic we could talk about, as a much lower CO2 imprint footprint. And I think that's why we wanted to talk about it. So real quick before we sort of talk to the speakers, who again, it's a small crowd, so I don't know if we have to go through full on intros, but we are on LinkedIn, CLF Austin. I think that worked out. I saw Adam and Samir, who've known each other forever, on LinkedIn. And so if you shared it, thank you. I think we made a post, and I think we'll do that again in the future moving forward. I think you could follow our page. Like a rock star or something. You can follow Bill Gates. You get to follow CLF Austin. You can't be our friend. You only get to follow us. It's very powerful. We have a website. Swarna made an awesome website, clfatx.com. We post the YouTube links to these recordings, and Swarna will talk. We probably need to update it and get the LinkedIn in there like like linked up somehow to this page, but you know, that also works for sort of the goings on. Myself, Greg, and Swarna are here for everyone on the CLF Austin side. Oh, I did want to mention the next meeting. We don't quite know what's going to happen yet, but we will figure something out. We might have one for, sometimes we would try crossover. So we might talk to Dallas and see what they have going on. Or I think Houston has a small CLF, so we might see what's going on with them. And if they're doing something big in November, December, we might just piggyback on that, kind of take a breath, CLF Austin, and get everyone moved on to their topic. Perhaps we'll see about that. And then we had a really nice discussion last year at the end of the year with a lot of folks who come to these often, sort of about what's hip right now. What are you dealing with? What should be put on the slate for next year? And I think, you know, everyone on this call, if you can make it, would be great to give us some ideas. You know, we know enough, but it's always good to hear from people out there to say, oh yeah, actually, this topic is a big deal these days that I'm dealing with. We can start to churn on that for next year. So those are some of the logistics. Again, we don't have to have a ton of guests, but there you go, Bill. I got you. And we from Woodworks, Ashley Cagle was supposed to be here. We were told she has COVID, so hopefully for speedy recovery there. But Bill and Mark from Woodworks, who are experts in all things mass timber and wood, and I know you all do a lot of consulting on things, and a lot of helpful documentation on how things go together and really just how to build in mass timber. You know, tons of knowledge there. Forrest Bratton is with us from WGI. Forrest, an engineer, structural engineer. So you've worked in mass timber and are working on some projects locally here in Austin. So that's great. And then Adam and Samir, architects like Flato. We know you all have done some mass timber buildings on the architectural side here and in San Antonio. So we just wanted to get you all on here. And, you know, like I said, in my mind, it was sort of like Woodworks might have some general knowledge about trends and what's happening. Forrest, I think, can sort of get into down and dirty of challenges that we've run into on site. Obviously, Adam and Samir can as well. And then, you know, Adam and Samir from you all, how things work with the clients. And I know you've done some developer work in this realm, and I think that that's always sort of tough, and where the rubber meets the road on some of this is sort of, if mass timber isn't ideal for one reason or another, or the pros and cons list, how does that work through with someone, with a client to say, hey, what can we do? How can we do this? What are our choices in mass timber to really reduce some of that embodied carbon? So I don't know how this is going to work. Again, we don't have too many folks here, so maybe it can just kind of be a free for all. But I was thinking we could use the hand up function, or you could use the chat if anyone have questions. But at this point, you can also probably just unmute and and kind of go at it. And I didn't have much more than that. I guess we could, if we wanted to go around the room, Bill and Mark, if you wanted to mention, I think it would be good to just talk about we do have to think about people who might watch this later, what you all are doing sort of locally in Texas. I always make the joke, but when you're in Seattle, you know, we get it. It's mass timber. People are doing it kind of. There's some buildings here and there on the coast. It's a little bit different in Texas. And then the same for Forrest and Adam and Samir. Maybe you just mentioned some of the projects you've worked on locally. And then, you know, if no one wants to jump in, you all know I have a million questions. So, you know, we can go for it. So why don't we go Woodworks, Forrest, and then Blake Flato could tell us a little about what they're doing here and locally.
Sure, I'll get us kicked off. So, you know, the mass timber momentum in the United States has really been exploding over the last couple of years. You know, in reality, we're talking about still something in its infancy. The first mass timber project in the United States came in around 2010, and there were very few at the start because obviously there were very few manufacturers at that point, and we've grown tremendously. And if you plot mass timber projects over time, you sort of see that logarithmic curve just sort of growing here in just the last couple of years. And it seems like I get maybe seems like 1 or 2 projects a week where somebody reaches out to me where they're considering mass timber for it. So The Austin market was probably the first one to adopt, to start to see mass timber projects going up. 901 East 6th Street, the Magdalena Hotel, and several more have followed, including the one that Forrest has worked on. San Antonio has a couple of mass timber projects. Houston has quite a few, and several that are steel mass timber hybrids, which is another interesting option that we have in the mass timber realm. And then lastly, the DFW market was a little bit behind the curve, but they are starting to catch up very quickly here. So it's a really interesting thing. One of the big advantages of mass timber construction is that it requires a relatively small, unskilled labor force. And in Texas, that was always something that I thought was not necessarily a positive for mass timber, because we always had abundant, inexpensive labor. But here, within the last couple of years, we've experienced our own labor shortages, and I think that bodes well for the future of mass timber, because it doesn't require as extensive a labor force as a reinforced concrete or post-tension concrete structure does. So, I am cautiously optimistic that labor won't be an issue in the future, and that obviously the beauty and the sustainability of mass timber is going to help to grow its market across the state. So.
Great. And I guess I'll jump in just from an introduction perspective. I'm Bill Parsons, based in Boise, Idaho, COO of Woodworks. And, really, Ashley's sorry she can't be here, but we thought this was an important conversation to engage on. We've really been working on carbon and how do we answer these embodied carbon questions. It's been something that I've been helping Ashley on. And so hopefully get to some great questions today. I think the biggest thing Woodworks is working on is we've seen this growth, and we want to make sure that we're providing all the information that we can related to how, forests and carbon. You can't really talk about just building a wood building without talking about where did it come from and what's the end of life going to be. So we've got a lot of resources related to that, and looking forward to sharing those today. And I've got a couple of things I'll probably put in the chat throughout this as we go, if that's okay. Including one of the first things I'll put in is like the map of the projects of where that's at. We've got a Woodworks Innovation Network is a system that we have that shows all of the projects in the US that are kind of crowdsourced from the design teams. So you guys can get a sense of what's been built in your area right from this first map there. So I'll turn it over to the other panelists.
That's great. And I was going to throw it to Forrest, I should say too. Feel free to share the screen. Again, this is sort of just kind of supposed to be a conversation. Whatever you want to know about mass timber. I know we've talked about some projects. Bill, feel free to share, right? Sort of share screen or pull it up, or I can track things down and share screen. So it's pretty wide open here if anyone wants to show and tell. So
I can jump in, Tom. I'm Adam from Lake Flato, project architect. Samir is also here from Lake Flato. Samir's involved in the Soto project in downtown San Antonio. What is that, 5-story mass timber on a podium, Samir? Is that right? Concrete podium?
Right. Yeah.
Yeah.
Mhm.
And so we've both been involved more in sort of the planning aspects of multifamily projects as well. Some in the Pacific Northwest. And yeah, I think exactly what Mark said is on point. It's it's really the idea that you can have this prefabricated structure that goes up pretty quickly on site. You're not dealing with form work like you would with concrete. It's less total workers in the field putting it up, and it's actually less time. A lot of that is very attractive. I would say, going back to your question too, Tom, about what are developers thinking and clients thinking and owners thinking. I think some of the more beautiful projects that have been built in the Pacific Northwest, especially the residential projects, I think have caught a lot of developers' attention, and they see this as sort of a marketable thing to have. All wood interiors, exposed wood ceilings that they don't have to add a finish to. wood columns. Gives it just, aesthetically, it's just a huge warmth to the space. And so I think that's been a big push, that they keep up with trends, right? If they're experienced multifamily developers, they understand, what their clients want. And so looking at this as a new product type that they can offer, I think is a big deal. We've had a lot of clients that come in and say, I want to do mass timber, and it really becomes a price issue. Obviously, sometimes things get VE down, right? And sometimes there are tariffs and other things that are out of our control if we're dealing with Canadian wood. But yeah, there's obviously a lot of aspects to it, and I'm sure Mark could talk more about it as well as Bill.
And I'd be happy to add some information, backstory to how this project came about in San Antonio. I know it's sort of a unique project for our city, but I think what allowed this project to come about is that this project is not just like developer driven; it's also like it's owner operated. And so the clients were looking at the market; they were looking at the portfolio of offices that were available in San Antonio, and they wanted to differentiate themselves. They didn't know about mass timber, so we initially brought that idea to the table and studied with them, and then provided them, information about the speed of construction, the reduction of CO2 emissions, just like all the potential benefits of this, and they were interested and they were willing to invest in it. And through this first project, there were a lot of design considerations that had to be sort of addressed, and the solution you see in front of you lent itself actually quite well in terms of the way we wanted to deal with the mechanical systems, delivering air low in this new era of COVID. That was just sort of a somewhat happy accident.
So it's interesting, Forrest, an architect comes to you and says, we're thinking mass timber. What happens in the structural engineer's office at that point?
Yeah, I mean, we're excited when people are interested in it. We've been able to look at options on a number of different projects, a few different office buildings where people are interested in it, a little bit in multifamily space. It was really the project that we've got in construction right now that's supposed to be finished this year, where we had that developer support for it. They kind of came to the table wanting to do a timber building, something that was unique, and so that was an exciting thing for us to be able to pursue and make a reality. There's certainly, we could get into all kinds of things about grid layouts and spans, and I think from a structural engineering perspective, it was interesting. Got the project pulled up there. There were a lot of things that we had to spearhead or help the team understand or chase down our own that we probably wouldn't normally do. And as just the structural engineer, because many things in this case, the project here, we had panels that were doing a lot of work in different ways. You've got a quasi podium here. It's podium in a structural sense, not the fire separation you think about. But anytime you penetrate that, it's the actual structure. It's not just some decking between trusses or something like that. There was a lot to chase down for the acoustics. Normally we're not thinking about that much. I think, we started this project back in 2017, actually, and it's taken this long for a number of different reasons, not because it was mass timber necessarily. And there's been a lot of advancement in the field, and I'm sure Mark or Bill could attest to that, just in terms of the resources that are available and the producers that are available. So, what seemed like 5 years ago, a pretty aggressive out there type of design, it's still unique, certainly still not something you see everywhere, but there's a lot more knowledge getting gained in the industry, which is, I think, going to make it more possible going forward.
Yeah, I'll jump in and add a little bit there because I think, when we first started talking about mass timber, I think the first few projects were almost to guinea pigs to a certain degree that, at that point, a lot of people didn't know what they didn't know. And so now we have these projects where we've learned so much that the newer projects that are coming on board are going a whole lot smoother than some of the first projects out of the gate, mainly due to what the contractor knowledge is and what the contractors need to be prepared for dealing with the material in the field and sourcing it and things of that nature. And we have a number of new additional providers of it over the last 10 years. So it's been, as you can imagine, the first few projects were probably a little bit rockier than obviously the ones that are coming up now, but we're really starting to see the material go up and be acquired through a much more smoother process. Now, I did see one of the questions come in about acoustic concerns with mass timber. So when we talk about acoustics with mass timber, there's an assembly that goes along with a mass timber floor system. It's typically exposed on the underside, which we want to do to expose the beauty of the wood. But the mass timber systems by themselves are not going to satisfy acoustical requirements, particularly for multifamily applications where there are code minimums for STC and IIC ratings, impact and sound. So typically the assembly of a mass timber floor system has the mass timber itself, and then above that, some sort of acoustical material to sort of provide a break for the impact transmission. Usually that's about an inch thick, half-inch to an inch thick material, depending on manufacturers. And then above that is going to be a topping slab, which also improves the acoustic characteristics, but also provides vibration resistance. It stabilizes the floor and gets a very good performing floor as far as the feel when you walk across it. And then above that is going to be whatever the typical finished floor system is going to be, whether it's a carpet, tile, and whatnot. Anything can go on top of that. So I'll see if I can find our typical floor assembly image. Just a seminar that discussed this a couple of days ago.
Yeah, and I was just going to share too. I can pull up what we spec'd at the Duke project, and where we. Well, I don't have an image of what we ended up with, but one of the things we were looking at is, in terms of utilizing the mass timber from the beginning, was you're trying to avoid the poured concrete. And that ultimately became a structural concern for us as well with the podium condition that we had. We were trying to keep the loads above that thick CLT panel as light as possible. There are limitations to how large the panel could be, and also just the cost of adding more and more mass to that panel. So let me go ahead and share this image here.
To say, Tom, I can't share my screen, so if you can turn.
Let's see if this works for me. Oh, apparently it's disabled. I can't share, but we had. I can describe it. Basically, a multi-layer buildup, including Acoustimat and layer of insulation and a couple layers of dense board. It was a more robust system than you're used to seeing on top of a floor, where in a truss system you might only have your decking and then gypcrete and then finish. And by the time you've got that and you've got the cavity and you've got ceiling below, you have a decent sound barrier, something like this. So we had to keep it lighter than that, and so that ended up just being a lot more to consider. And when they went back and tried to reduce the costs of the buildup we had originally started with, it was a lot of how do we get there again with the maximum. We had a 12 pounds per square foot limit on the weight it could be. Most of these poured toppings sort of start out in the 19-20 pounds a square foot and go up from there. If you've got several inches of concrete, you could be a couple times that. So just another challenge to think through.
Sorry about that, Forrest. Everyone should be able to share now, I think.
Okay.
So you did just share, right, Forrest? So we should be good.
That was me sharing, but yeah.
Oh,
so
sorry.
Here's my images from Forrest's project. So this was before you put in insulation within this cavity in the floor system.
Yeah, so that's interesting. I'm glad you have that photo. So this is the sort of VE option that was landed on. In between all and within all those squares is open. I actually don't remember if it's open cell or closed cell foam, but spray in foam insulation within that space, and then there's another decking on top of that before the finished floor. This is not where we started out, but this ended up. They were sort of backed into a corner trying to find something light enough and something they could afford. And this is what they landed on. It's not a tested assembly. So if they've got to prove it, it's going to have to be field tested. Hopefully it works out. They apparently were satisfied with their unscientific field tests at this point. But I'll just show you real quick what we started out with on the project.
Yeah. Having done this same search for an alternative to poured in place topping slabs, yeah, it'd be great to know if there's any kind of sleeper system like this, or that is tested, or that we could use, on future projects.
Can you guys see my screen here?
Yes.
Okay. Yeah, so this is the original, lost it. The original assembly that was spec'd. So you can see there's a number of different things. We have got polystyrene, and then plywood, and then an Acoustomat, more OSB or plywood, fiberboard. So it was a lot of pieces, parts to make that work. Right, but Woodworks has a really helpful list that we looked through trying to find an option here for different buildups on top of CLT. And this may be old. This was the one from 2021. But essentially we just kept coming back to, we only can accommodate 12 pounds a square foot. And so everything we were looking at, like, what are our options here? We don't have any other options. So they came up with this other assembly that, at least the foam manufacturer said that they could get their STC ratings. I'm a little bit concerned about how the impact sound will be transferred, but maybe it works out. I know they worked through a lot of different options on that. So there's certainly not, at least to my knowledge, there's not a yes, definitely do this if you're not trying to do a poured topping. I mean, unless you're willing to do something like what's on the screen here.
So there are also options we've seen, instead of a wet topping, a dry topping with basically using drywall to provide some additional mass and and sound resistance as well.
Yep.
One of the things I think it's really important when you're considering a mass timber project is that there are a lot of decisions that need to be made very early in the project that affect a lot of different things. And you think about acoustics, that might be something that you can put off until later. But it's a huge impact on the CLT slab, depending on the thickness of the CLT, or I'm going to say mass timber because it could be DLT as well. But how much topping slab obviously affects the overall weight. It affects the acoustics. It affects how far the material can span. So there's all these things that sort of go into early design decisions that can really be important on whether mass timber makes sense and is designed efficiently, or you come down the road and you realize you're going to have to, jump through a few hoops to try and figure out, how your acoustics work based on, you weren't considering that early in the project, or your MEP layouts, things of that nature. So it's, and that's one of the great things I think about Woodworks and about what I do is that, I can sit down with a design team very early in the project and make sure that all of those boxes are getting checked to make sure that those things are being considered. And then we come up with a design that gives mass timber the best chance of being utilized as the structural material.
Yeah, and if I could just jump back in real quick, we were in a unique situation too. In many cases, the poured topping would be just fine, particularly in a more traditional post and beam type of structure where you're not building up load down to the lowest level. I'll share again real quick, just for anyone who's not familiar with this project. It's a sort of hybrid mass timber light frame building. And so the upper floors, we've got CLT panels at the roof and upper floors. That load's coming down in our bearing walls within and between apartment units. And then below that, all of those bearing walls are getting picked up by this heavy CLT plate and then spread out to beams below that don't match up with the demising walls and bearing walls above. And so because we had several floors worth of load building up onto this single panel you see here in green, the project was particularly sensitive to, an extra 5 to 10 pounds a square foot per floor, because it was building up. And of course, yeah, I don't know if we talked about this or not, but a lot of this comes back to if you're trying to expose the underside of the CLT. If you're not trying to expose the underside, well, then it's, much less difficult to get your acoustic isolation depending on the project.
Well, that was something I also wanted to mention too on that is, between floors is one thing, sort of in room is another thing too. And, just thinking off the top of my head, core learning spaces, lead, your STCs and your reverb calcs and that sort of thing. You want to expose this beautiful structure, but I do think in room, there are also things to consider on what the flooring is. And then, one of the advantages, you don't have to drop a ceiling because you could sort of look up at the structure and it's awesome. And if your MEP sort of gets in line and we run everything in the places where it, is at least in one line and not all over the place, I think it can look great, but you do need to consider that about what are the rooms going to be used for and what will be the acoustic treatments in and around, because you want to expose some of the structure, but maybe not all of it. And this sort of concerns people think about that. I think it's pretty common, obviously, in the architectural world, but just another thing to think about like, oh, mass timber, open office would be fantastic. Sort of Mark's background looks amazing, fair, but if you have 50 people talking on the phone at one time in there, you're gonna have to think about how that works out sort of in room as well.
So I have a quick question too, Samir, on Soto. You guys did a raised floor, raised floor of pedestals system. But did they put topping slabs on the wood?
Yeah, so a summary of the buildup is the DLT project. We had 1/2-inch ply with 1-inch gypcrete and then a 7-inch pedestal system. The pedestal system was selected because, again, the office is leasable, and so there's the concern about tenant ownership and installation of lights, and we couldn't have tenants drilling from above to get down. We didn't want to cover up all that beautiful ceiling, and so the pedestal system was a great solution for that, and it also helps management of we force air and able to deliver clean air more efficiently at a higher temperature low, and then do the return from above in a plenum space at the core. And so that was I guess a great decision overall.
Yeah, get rid of duct work so you have kind of a really good visual on
That's
all
right.
all the wood slabs above.
Yeah,
that's a great point. So about when I think about ducts and all that stuff, but yet it's something else to consider, but you can sort of work around it with a little bit of foresight, architectural magic on coordination. There are a couple questions in the chat. Mark, do you want me to jump over there? I think, well,
yeah, I see the chat here. I see one question
Okay.
from Swarna about MEP coordination. So I'll go back real quick just to have the visual. Share my screen real quick. Nope, there we are. So, on the lowest level, we had the series of glulam beams all running basically in the same direction. So the idea was they could, for that retail space of the ground floor, ductwork can run in between the large girders. Because I believe our glulam girders, they got changed as a VE item from, I think, Doug fir they originally were, to a Norwegian spruce. Reasons I can also go into. So they got a little bit larger, but I think the deepest ones were 33 inches deep. They're pretty hefty. So the idea was to keep those running in one direction, so the ductwork could run in between for the most part. And there's a portion near the front where it crosses underneath. At the upper levels, it was, more similar to a standard multifamily. Of course, we had stick form bearing wall systems, light frame bearing walls. The main issue that we had to work with MEP wise is actually not so much the duct work, which was at the upper levels relatively straightforward. It was the plumbing penetrations. In multifamily, of course, there's a lot of penetrations coming down through, and all of those had to be coordinated with structure, because every time you penetrate the panel, that's a structural penetration. So is working with MEP to get as many of those in a line along the span of the CLT. So we're not putting penetrations next to each other that are essentially cutting off the structure as it spans between walls. So that was one element of it. And the other is just it becomes similar to, in a concrete structure for multifamily, you've got a podium structure. We have to know as a structural engineer where all those penetrations are being located in that concrete slab, so we can evaluate the structural impact. And so it becomes a similar process for each of the floors that we're putting plumbing penetrations through, that we're spanning with CLT, to be able to have that back and forth with MEP on where those can go, where they don't affect structure or don't affect it too much. And then one of the things in the construction side of this that became a challenge, I think because of everyone learning the process. So we were working with, and I think this would be true of any manufacturer, we were working with KLH out of Austria, who were phenomenal partners on it. They provided a lot of technical support to us, which is generally true of all the CLT manufacturers, both in the States and abroad, is that they're all have technical departments that are wanting to help this become reality. But in any case, they wanted us to locate as many penetrations as possible so they could pre-cut them, because it can be difficult to cut the cores in the field. And so we had essentially a CAD document that was discussed and shared to try to coordinate those ahead of time. But for various reasons, that process was compressed, and in hindsight, maybe a little faster than it ought to have been. But some of those plumbing penetrations didn't end up in the right place, and so then it became a field issue. How do you cut through a panel where the plumbing penetration's 7 inches or 5 inches away from where it needs to be? Not only on the structural side, we've now got to make sure the 2 holes aren't a problem, as well as just figuring out how to work with that practically in the field. I think probably the GC, I don't want to speak too much for him, but I think he came away from it wishing they had just budgeted to cut all the holes in the field, which is kind of the opposite of what you hear from most people, like, oh, you should just plan it all in advance and pre-cut it and it'll be great. I think his feeling was at the end, well, if I'm going to have to cut a whole bunch of them anyway, why don't I just plan to do that? So I think it's probably dependent on the installer and on the process that's given to that coordination early on. I think if you approach the project thinking it's going to be like a normal multifamily construction, and particularly if the subs don't understand the difference, that's where there could be that difficulty. I think if you go in knowing, hey, we need to spend whatever it is, an extra week or an extra 2 weeks in coordination during the design phase to get this right, I think that could certainly be successful. It's if you try to compress that can be issues. Kind of talked around that issue, but I think that's some of the stuff we ran into on this one.
Forrest, one of the questions I had, so I'm gonna, if you can let me share my screen, I got a couple of images that I took when I was visiting the job site. So
sure.
One, let me show this one right here. So it looked like you did have some chases in some areas. Would that be something that you think, trying to locate larger chases where necessarily the penetrations don't have to be in an exact spot? Would that be, would you think that would work better, or do you think that would be challenging because you're trying to now have a larger opening to design within your panels?
It's a little bit hard to give a blanket answer on that. I think in general, yes, it's easier in the sense that, if we've got a chase, usually everyone's pretty well on board that, hey, there's a chase here, we're planning for it, versus, some smaller penetrations can catch you off guard if you're just assuming they go down wherever they want to. I don't know how well that works to try to group those when you're, I guess it depends on how far your horizontal runs have to be to make it to those chases. In our case, at the upper floors, that the chases were helpful. We could have bearing walls around them, so they weren't too much of a challenge to, you know, support the panels around those chases. We weren't trying to make the panels do all the work to span around it. I would say, I mean, generally speaking, I think probably our MEP engineer friends would agree that planning for a little bit of extra chase space always makes your life easier in the field.
Okay. And then the other thing I wanted to point out was this image here. So when you're doing a multifamily project, you have a decision to make whether you want to expose the mass timber in the corridor or not. And obviously, in this case here, you know, you're utilizing that corridor ceiling space for a lot of the MEP equipment, and you will not be able to expose it. And if you do want to expose the corridors, then that means basically that all of this is going to be forced into the units themselves. And so you're going to have to cover it at some point. So that's just
I think
one of the decisions. Yeah.
Yeah. Generally the you know, the leasable space is the unit side that they're trying to expose as much as they could in the units. And then, yeah, the corridors are getting covered up here.
Yeah, exactly. So
There were a few other questions in the chat I thought I might jump into quickly. Forced not to put you back on the spot, but Mark Ledger had a question just sort of going back to the acoustics that I feel like you could sort of handle quickly. There might be a lot of answers to this, but essentially, what are the implications of designing a structure that could accommodate the extra load for the acoustics? So I'm imagining if you were just saying, okay, we are doing topping slab, or we're doing whatever the norm is, sort of how does that impact? Are there more members, sizes change? What kind of comes from
in our case? You know, of course, if you're adding load, then in general member sizes are getting larger. That's a typical rule. But in our case, it was looking back at a poured topping after design was essentially complete, and we had gone with this system that included that, particularly including that panel at level 2 that's supporting the offset walls above. And we were already using essentially the strongest panel that KLH produces, or at least produced at the time. It's a 11-inch thick panel, their highest stress rating panel, to make those spans with all the load coming down onto it. Because I want to say the total load per square foot on those panels was on the order of 250 pounds a square foot, something, you know, large, you know, in terms of a area load, smear load, we call it. And so, you know, bumping that up by 20% was just more than we could do with the system as designed. So it would have meant a pretty wholesale change in how we design it, because that, you know, the concept was to keep the panels alone doing the spanning, and they cantilever off the ends of the building past the girders as well. And we would have been in a situation where you're adding intermediate beams as a sort of another layer within the structure at the podium. So you're increasing the structure depth probably significantly, a foot or more. So it was a compounding thing on our end, where we were just already too close to the limit of what we could do with the panel that was available. So it wasn't just a simple, you know, go from 11-inch panel to 12-inch panel and it's fine. It was, we were maxed out. We can't do this.
One of the things I noticed, you know, in this image I've pulled up here, you know, you've got basically a beam spanning across an opening, and obviously you've got a multi-wide column coming down, and then you've got additional steel to distribute that load even further, because again, trying to put a large point load onto a CLT panel can be challenging.
Right.
When they're really designed for a uniform load.
Right. And the idea behind these, we had these in, I think there were 8 places. So, you know, it's essentially an all timber building, but you can't get away from steel. Obviously, there's steel in the screws, and there's steel in a few different places, and this is one of them. Essentially a bearing beam, or a really hefty base plate, if you will, just so we didn't have issues with localized crushing or potentially punching through that CLT panel. So it's a 4-foot long steel tube piece that's your picture here was taken before it was corrected, actually. Oriented across the CLT panel. It's 90 degrees off in this picture, but to spread the load across the panel width.
I mean, the whole thing, this whole project, it's an interesting choice, right? Because all your floors are CLT panels, right? All the way up.
Right.
So what you're gaining by making this sort of combined load bearing wall and CLT structure is a freedom to make the floor plan layouts at level 2 and up, you know, whatever you want to make of them, right? Because all the walls become load bearing, as opposed to some of the structures that we're working on where it's all glulam beams, mass timber columns, CLT panels, or dowel laminate panels or something like that, but it's purely a mass timber structure. And you're kind of, you just have to live with wherever those columns are, taking the loads down from, you know, the very top of 11 or 8 stories or something like that.
Right.
Something that I don't, yeah,
Go
something that I don't know that, let me make sure I'm sharing the right screen here. Don't think I am. Something that was brought up to me recently that I didn't really internalize until now is that if you look at, you guys see the building code on the screen?
Yeah.
If you look at the mass timber types, right? It's type 4, A, B, and C, right? These are at the minimum, type 4C is equivalent to type 1B in its fire ratings. So when you're thinking about mass timber as like a large structure, you should kind of be thinking about it as very analogous to concrete in its weight and its heft and what you're doing with the structure. So I think it's really fascinating for us, this kind of combination of light framing and you know, mass timber floors and diaphragm, and kind of what is the benefit of that versus a purely mass timber structure, right?
Right. I think you said it exactly. It was just the flexibility to do with the unit layouts what you wanted to with the upper floors, and not be constricted to, you know, a column grid that's dropping those columns in all of your units. It's a relatively small site. I think they were trying to maximize the availability of unit layouts without being, you know, losing dead space because of columns. You know, if they had to do it over again, I don't know if we do it the same way or not. I honestly,
yeah, it came with a lot of tricky conditions, right?
From a structural perspective, it certainly would have been easier. We always love it when loads come straight down to the ground, but sometimes it's not what the project demands. So you certainly couldn't do this system much higher, right? You could do a timber podium that goes higher, but we would have to have, we'd still have to constrain the loads a little bit, or the walls above a little bit, so we could put beams below them instead of just the flat panel. Because like I said, we're already kind of maxing out the panel in this type of layout. So it has uses in some range of buildings. Yeah, most of what you see is the more traditional post and beam, and you just got to move with the columns.
So from a code perspective, what is the type of construction sort of above and below?
It's 5A, the whole building, I believe. Although I feel like I was just looking at the architect's drawings recently, and they had called it out as 4 at the first floor, but I don't think that's right. I think it ended up being permitted as 5A throughout.
So I don't know if you know, Mark, is there any provision that's going to happen anytime soon as to make 5/2 with 2 stories being mass timber instead of concrete? Is there any of that in the works, you think?
There are some provisions within the code that allows a type 4 podium with only parking below. But it's, you know, you have those challenges that Forest had on this project, is that you have all these load bearing walls, and that can you get a grid below that'll work with your system above. Now, if you're doing a post and beam above with the same grid as the parking, then that makes it a lot easier to justify. The problem with multifamily, though, or not a problem, but the issue with multifamily is that you still have to have rated construction between the units. And so if you're going to have to build rated walls, it would be great if those walls could be load bearing, and then they, you know, could be pulling double duty. Whereas in a pure post and beam building, those walls would be non-load bearing, but you would still have to come in and do rated construction. So it's not going to be as inexpensive as it would be if it was an unrated construction. So, but yeah, we've got an expert tip on our website that talks about the ability to utilize a mass timber podium. So there's some information on it. I don't know of any future code changes that are going to make it a little bit more flexible, but I think, there's just certain things that, unfortunately the concrete can do better than wood can. And obviously a podium distributing loads is one of those things. So.
For sure. I've always been curious, do you see people doing that type 4 podium with parking underneath? As a structural engineer, it makes me a little bit nervous to have wood columns in my parking garage.
I've been asked about it a lot. I've never actually had a project that's gone forward with that approach. Bill, have you heard of any? I mean, those are like one in California.
Yeah, there's only a couple across the country where they've tried it, because you have to have very specific things about what is allowed in that parking part, right?
Right.
It's got to really thread the needle. And it was a very small building overall. I mean, that's part of it, right? We're not talking about scale buildings that you guys have described today. It's pretty small.
Yeah, and just in terms of durability, if you run your car into a concrete column, the car loses generally. But I don't know if the same holds true if you hit a wood column.
Just do lots of
Have you ever seen a car hit a tree? The car loses that one too.
Well, that's true. That's true.
There are lots of bollards around for us. Don't worry. Lots of wide protection around. So I did. There is a question in the chat. So Swarna, I see your question. I wanna jump past it for a second and then maybe come back to it if that's okay. Sorry, Swarna. Well, Forrest. We can always. We can come back to that one. The structural engineers can talk about that for a long period of time. I did want to. Ruth had a question, well, Forrest, I'd wonder your thoughts on this if you do a lot of LCA, but certainly Samir and Adam can talk to this, I would imagine, and I also can, having done a lot of these. There's a carbon study performed and alternate structural systems looked at to understand relative impacts systems on this project, but it could probably be any project. I know you all have done hotel and Soto. If so, how did wood and mass timber compare? And I could certainly say from just from an LCA perspective and a carbon output perspective, when I do a lot of comparisons, I'm usually seeing anyone, if you think of a building as sort of a concrete building, and then you think it's sort of a mass timber building, which usually is, in my experience, sort of concrete foundations, walls, piers underneath. Sorry, there's a little bit of a pin up in front of me right now. You're getting background noise, but but then sort of mass timber above. I've seen anywhere from a 30 to a 50%, usually somewhere in the 40 range, reduction in CO2 output, and that's assuming sort of a similar cladding system, obviously insulation, a lot of the interiors start to build up over time, gyp inside walls, that sort of thing. But that's just sort of looking at a structural frame in mass timber versus what would have been in concrete. But I don't know if Adam and Samir with the developer projects, obviously you guys have rule of thumb numbers, but were you doing tally analyses, assuming it's tally at Lake Plato early on, and did you get those numbers out to folks and kind of change the narrative that way?
Probably a better question for Samir. I know there have been some studies done by Kate Sector and Ryan Yaden in our office, and I don't know if the result was as clear as 40 or 50% sort of better than concrete. It seemed like it might have been closer than that, but that wood does win out in the end. But I don't know, Samir, is that what?
I'm having a hard time remembering exactly what happened. We did some initial studies, and I recall it was a 40% reduction, and that was, take into account, we work with structure craft in Canada. Our beams were coming from Austria, and including all the shipment, the boating, the trucking, it still was a 40% reduction, and it's not even FSC certified wood. So it's you could get even higher if you go that route. It's out of the budget range though.
So one of the recent projects that I had an opportunity to tour, I'll pull up and share my screen here. This isn't a necessarily a glamorous project. It's a warehouse project, but it was interesting for the exterior wall system. Uh-oh. Can you guys? I got a message saying Zoom just quit on me. That's weird.
We can still see you. It was a little glitchy for a second.
Well, in and out, Mark, but we can see your screen.
Okay, so anyway, so this project, they didn't replace, they, instead of doing concrete tilt wall, they used mass timber for the walls, and their carbon impact was 45% on this project. And so USAA Real Estate was the developer on this, and that was one of their main motivations behind it. They were looking to attract tenants into this warehouse space that would be interested in reducing their carbon footprint. And so, you know, they had a 45% reduction in carbon on this project. So.
Yeah, that's fantastic. Yeah, I like I said, I think that usually around the 40% is where I see things. But there are a lot of dependencies. Again, Samir, you're right on sort of FSC wood and getting better. And I know like EC3, you could look around, find different manufacturer things to sort of further crank some of that CO2 equivalent down. And you know, obviously sort of steel and hybrids, and it depends on the steel, but you get pretty high performing steel in the CO2 realm, obviously, with very high recycled content. So you know, it kind of all depends. But
could I jump in on maybe an example?
Yeah.
I prematurely hit enter and shared this already, but the LCA was a comparative LCA related to the Plat 15 project, the office building. Actually, Mark is sitting in this virtual background, but the results on that, I think, really do demonstrate the difference when you start looking at the settings and some of the defaults that are included in Tally, and really understanding what is in there and what is not in there. And I'm super excited to get into this part of the conversation, because I think we can go into a lot of the how to pull off a mass timber building with the volume of buildings we have now, and love to talk about that. But I think getting to the real clear apples to apples understanding of what is in the tools and what assumptions you make throughout that's something that we're really working on helping. And this was like one of our first ones that the KLNA, the engineers who did the project, are the ones who did the comparative design and also ran Tally on this project. But this is, you know, I'm just showing, this is like the money image at the end, obviously, the take home, like this is the final deal, but it was a cost comparison and an LCA. But there's 27 pages here that describe how they went about it and what the settings were. And I think that's really important to get into, and it's not a smaller percentage. It's really this 3x, 5x kind of deal. We're about the developers on the Lennox project, a tallwood project in Boston, just completed an LCA on that's going to come out, and that's steel versus wood. You know, they built the wood building, they redesigned it in steel and did an LCA. That's actually 5x comparison to steel and wood. The reduction wise, you know, so there's a significant amount, and it really depends on the settings and some of the assumptions I think that you guys are talking about related to that. And we've got a number of expert tips. We've got 4 of them that are out right now, and I'll put the links in just so that, you know, people that watch this can get them as well. So there's lots of confusion around how you deal with biogenic carbon, what happens, what EPDs are available to go into the actual study. And should you use a tool like EC3 to really do a comparison across products? It's really great at the procurement stage, but not fantastic comparing across products that aren't, because the product category rules are really different. So looking at them and from a full building LCA perspective at the end, when they've been harmonized by the LCA tool developers, I think is really critical. So using a Tally, OneClick, or Athena to do that is really important. And then where the wood comes from, I think, is also something maybe we should chat about a little bit, because the FSC side of things there's an impression based on the settings and tools that makes a difference, but it actually doesn't make a difference from the carbon perspective. It shouldn't be driving the results related to certification of wood or what happens because of where wood comes in the US and the projects you're talking about. And when you're using US manufacturers or North American manufacturers, the lumber is from a carbon stock that is increasing, and there's settings in the tools that make it look like you should, maybe is it a question or not? And we've got some information that we're producing related to that really shows that you should be checking those boxes. And if you check those boxes, because of the way how we're managing our forests in North America, that these are the kind of results you should see. So kind of a all-encompassing statement with a lot of different things there, but happy to kind of dive into whatever you guys would like to go.
No, I think that's great. I mean, there have been a couple questions in the chat. Bill sort of, I think Sworn had asked about thoughts on reclaimed wood and as a sustainability perspective, adaptive reuse, and how it can be applicable sort of in the realm of wood structures. And I think that's a question. And Ruth asked thoughts on sort of where wood comes from, accounting for shipping. Not sure if there's a connection there, but I guess for me, I'm getting an idea of sort of the life cycle of wood in general, and where's it coming from? And you had mentioned sort of North America, which makes sense. I guess I'm thinking on a macro scale about forest management and some of those practices. And I guess for me, it would be, is there a difference in FSC versus not, even if it's North American or American produced? Maybe how does that work in accounting for coming to the site? And then Swarna, you can jump in, but when I see your question, I sort of more think of like even end of life and reuse or sort of adaptive reuse of these spaces. But when wood starts to get old, and this is starting to touch on the biogenic side, I don't know, Bill, if that keys anything up for you to go in on, but I do think about that and what that life cycle is and how we best manage that.
Yeah, it's like kind of mentioned in the opening, you can't really talk about, okay, what's this, how do you measure the sustainability without talking about where did it come from, what's it going to be in the end, and the whole, what's the life cycle, obviously, I guess, Captain Obvious a bit. But I think that the talking about the end of life, I think it's getting to the question from the chat is good, because there is, we've got these solid wood panels, right? These very large wood panels. And we're like, okay, what's going to happen with them when the building's done is a very valid question. And we have experience from projects that have used very large wood beams, these warehouses from the turn of the century that are all being refurbished and all being reused. I don't think there's a lot of places where they just say, like, let's just throw that all away and start over. I mean, there's a lot of examples of projects that have been built, those warehouse structures being repurposed, reclaiming. Federal Center South and Seattle's a great example of that, where they really took apart the building, scanned every piece and put it back together. Hopefully it's not that hard to do. There's projects, the Apex Clean Energy Building is a tall wood project in Charlotte, Virginia, and Charlottesville, Virginia, excuse me. That project was built to be deconstructed. So they designed the connections in a way that they can start to pull it apart at the end, because they know at some point someone's going to want to do that. So there's a lot of discussion around connection design. How does that work? Of course, composite slabs and how the details around how you do that and what would happen and how difficult that would be. But I think that there's the reality of how do you think about it ahead of time. There's a lot of those examples, the project we just saw, that that becomes difficult. But I think that you might lose some inches on the end of the connections, even if you didn't really design it, and you're going to take those beams and do something else with them. So I think there's that part. Then there's the part of how the tools will actually utilize that. They all make different assumptions. One click at Athena and tallying, and we're working with all three of them to help explain their methodologies, because they're not very transparent around how they go about it. And we have a tip that's about to come out related to the details of end of life and what all their assumptions are, because they all make a different assumption. It's not really based on any standard. They just kind of make an assumption. So there's some models related to what happens when wood goes into a landfill that can be used. And those methodologies then have basically an amount of carbon that's stored in the ground permanently. And that can be kind of then be part of biogenic carbon that doesn't get released at the end of life. So you could, even actually if you're doing a whole building LCA on one building and you're going to reuse those panels, that's essentially an emission of the one building. You don't get to really keep those anyway. So they're not, even the reuse has some value, but the, it doesn't actually help you on the LCA analysis actually. The other part of that is actually the time value of carbon is not really in LCAs today. So even with these results around how an LCA does, even if you put a lot of, the assumptions that show this 30–40% reduction, carbon being stored now is more important than carbon at the end of life, right? So how do we think of the time value of carbon? Not really even in the studies and in the LCA analysis. So there's a lot of aspects of all of that. So that's kind of the end of life thing. And so we'll get a lot more information out. Wish that tip was done, but that's not quite there. Mark put the 4 tips that we do have released. And it's kind of the beginning of the flow of information here, but just generally around how this works. We've got one that's about to come out on even more details on biogenic carbon, how biogenic carbon, this one that's in there is really the first version, the first step of that, just to explain kind of the terminology. The next is a big diagram of biogenic carbon and how it's released and what assumptions are being made into, what's in the EPDs, and then how does it, and from the PCR all the way through, then all the releases that are basically calculated through an LCA. So you see that, and then how each tool does it slightly differently, and where they report it is also super funky because it's all done quite differently throughout there. So there's some pieces there. The one on carbon stored in wood products, I think actually gets to your FSC question. It's, what volume of carbon is stored in wood is actually just the equation of photosynthesis, not really how the forest management and what happens there. Because the way that you're taking this volume of what goes into the building and it's based on the PCR, which really explains, does the math, and that math really does not deal with the forest management side of things, because it's really about the carbon in the wood is what you're really calculating, not the other side of things. So the way that the PCR is set up is that it has to be from a sustainable and growing carbon stock and forest stock. So that in North America, we have a series of regulations and rules related to how the forest is managed, which we have expert tip on, working forest, public forest, state land, tribal land, et cetera, that we're kind of coming out with all of those rules that are layered on top of them. And then Canadian wood also in their leases and things has a whole another side discussion related to that. So there's all these layers of regulations before you get to essentially the easy button of having a third-party verifier on that. And so describing kind of those differences of that forest management, how that works is kind of the next upcoming tip. It's been translated for foresters to understand, but not really for the design community. And that's kind of what role we're trying to do, is try to translate between the two items. But you kind of have these layers of regulations, and then on top of that, you can use a forest certification system to do it, but it's not really indicative of where structural wood in North America comes from. I'll leave it at that, I guess. It's a long answer.
No, that's great, and I really appreciate the links, because I certainly need to check some of these out. I do a million LCAs and actually do a lot of comparisons. And it'd be good to sort of, but it's hard to break open the back end of a lot of these programs that we kind of use. It's always good to know kind of what's going on. You can click the biogenic carbon button and then you run it. And it's kind of, it's kind of some of our the level of
and it's I think the other one that's also interesting is just generally what EPDs are available for wood is also something I think that's always been a question. And it's like, why are there not EPDs? And it's like, well, the EPDs are kind of there for a reason, the way we've created them in a system. We don't have mill-specific EPDs or the manufacturer-specific EPDs released, mainly because you've never been able to really buy wood that way. You can't really go, I want this stick from this person. That's why we set it up like the system. I think, you know, the wood industry actually is the first to have EPDs overall, but we get a lot of chatter related to, well, why don't you have the mill specific stuff? You guys must be hiding something. And really it's just because, like, how are you going to buy it is really the question that comes down to it. And then within the tools, there's a whole lot for them to do to take those EPDs that do exist on an individual level, because different manufacturers have produced them, and certainly CLT you're going to buy more directly. So then that makes sense if you want to procure an EPD for that. But the tool then has to take that in and then harmonize it with the rest of the work, which takes a lot of work on their end. So they just only put in a few things. So Tally, for example, has got some European glue lam, and that's about it. But there's other EPDs available. They just haven't gone through the effort to do that. And so we have that one expert tip on all the EPDs that are available, just so everyone's aware. And they're not all on EC3 either, just for that early phase in, you know, A1, A3 analysis. Yeah. So there's a lot there, and it's we're working towards, you know, showing the variability, I think, is one of the big questions that always comes up. So what is the variability of the industry average EPD? And there'll be some new data released on that so that everyone can kind of understand what's there. And so we're just, you know, I think our whole thing is as much transparency as everyone would like is what we're really trying to go for with all this information. So keep the questions coming and look for more information soon.
Yeah, and that's an interesting point too about sort of the Tally. I mean, I'm just a Tally user. It's just been that way. I don't know, we, you know, friends of Kieran Timberlake back in the day, you know, on and on. So we use Tally, and then EC3 coming in now. And it is an interesting workflow of what does Tally tell you, and then do you get to the point where you go into EC3 and get more specific. But I've certainly seen those products. Though I've been across a lot of those products. Whatever's in Tally, I probably clicked on it at some point. I think nearly every single entry in Tally I've probably put into something over the years, including on some of the mass timber and some of the wood. So yeah, and I guess I should say I'm looking at Nick posed a question, which I will. Okay, so Nick seems to be really in it here, which is good on the LCA side. I, as a Tally sort of EC3 person, but we've also, for any future viewers of this, we've also talked to folks from One Click LCA, and we've also given, I think, last year sort of a full tutorial on Athena. So all the choices kind of are out there, and I think we've also even hit on, you know, Kaleidoscope from Payet, and just even like build carbon neutral .org, I think it is. It's just like some of the real quick, you know, everything from the real quick estimators to sort of the middle ground to sort of the really intense ones. So if anyone wants to go back in the archives and see some of the presentations that we've done, and CLF National's done a lot of that too. So I'm just quickly, Nick, looking at your question comment, 40-ish% in a steel versus timber building. So that reduction, undershooting some of the distances in Athena, giving some of the transport distances. I know you can change those in Tally, and I think so in Athena as well, but that is something certainly to consider. Smog increase, structural system comparisons, recommendation for quantified impacts transporting timber from forest to mill to project site. Are there any recommendations for quantifying impacts transporting timber from forest to mill to project site? I think this comes from a possibility of smog creation via transportation. I don't necessarily have any of that, Nick. I can say I've certainly seen odd numbers in Tally just based on some of their back-end assumptions that they're making. And I know about Athena that have sort of thrown me for a loop over time, thinking that, you know, this one thing versus that one thing, why could there be such a difference with something sort of in the background churning that's kicking one of these categories? We're looking at smog potential here in this question, but I don't have anything on that off the top of my head. I don't know if anyone else, Bill, I saw you sort of intently looking. Maybe you have something.
Well, I think one of the tricky things related to it is kind of what is the base data that the tools are using, and that's something that we're trying to dig into. So some of it is based on there's the adhesives that are used, but then what root data do the tools, individual tools use to then create those flows from like what system and what version of the EPDs are they using? Sometimes they're using older EPDs or not the most up-to-date, or maybe not even a North American EPD that does have some root data related to the adhesives that kind of cause some issues. As I've seen that on some projects. The other thing is related to the A4 stage and transportation and what happens. One of the things that we've working on related to lumber in general is providing kind of what was some more statistics to the tools to improve their A4 step and their base assumptions. This one sounds like a site-specific one, but in general, they just have these really raw assumptions, and we just put together a bunch of data related to was the main lumber in that region, was it shipped by rail or by truck? What percentage is from the region or versus out of region, and what was the distance and the average distances? So all of this kind of really robust look at what those shipping assumptions should be has just been provided to, we had a call probably within the last month with all of the major manufacturers of these tools and talk to them about, okay, this is available, but then they have to take that step and implement it. And I think that's always a struggle for them, is all the priorities of software development and how do you kind of take that in. So I think a lot of it's the root database that they utilize, and then the update on the EPDs, if they're actually taking the newest stuff or not, and then if they're making the right assumptions on A4. Certainly we've seen this, the distance drive it a bit, but not significantly, because there's not that much of a radius around where, I mean, there's a difference, of course, I guess, getting for Texas from British Columbia, Pacific Northwest versus some of the ones now that you have in your backyard in Alabama and Arkansas. But I wouldn't think that would be, the bar might go up, but as you zoom out, is the bar really that much different? I don't know. And one thing we've talked about manufacturers a lot. I'll put a link to the manufacturer sheet we have. That is the list of who to contact about where you get product in North America and how that works. So if there are questions on that, we're really working with pretty much everyone on getting out there with us and who you can get.
Well,
go ahead.
And I appreciate the point about certain manufacturers. I mean, I know we work in concrete and we're really pushing EPDs to the point where I'm on projects now where we have structural engineers just giving sort of blanket global warming potential reductions. And Nick, to your point, obviously there are other categories that we look at, the 7+ different categories that we look at when we're looking through LCAs, and they're all important. And in the lead world, you have to hit certain numbers on, I think, 3 at a minimum. So it is definitely part of the conversation for sure. But we are trying to push concrete manufacturers, obviously, and with some of those numbers where we just say, this is the GWP reduction you have to hit. The only way they can prove that is through sort of mixed specific EPDs. But there's a good point, Bill. I appreciate that it can be more complicated sort of in the wood world right now. Yeah, so we don't have too much time left, about 7 minutes left. I didn't know if anyone else had any other questions they wanted to jump in on sort of before we close this out. I mean, I guess my general question, putting this out there to everyone, is sort of, what do we see the future as? I mean, where are we going? We know that we have this renewable resource. Is it a truly renewable resource? I assume obviously we need less consumption and maybe we get into hybrid structures. Like I said, I'm not trying to demonize concrete. We talk to folks all the time who are doing great work to reduce the global warming potential in concrete and this and that. In general, forest health, the ability to turn these over, I presume we can't change everything to be mass timber tomorrow. What's sort of the market future of how it starts to interplay with some of the other materials that we're using for our structures, and what do we see in 10 years from now? Is that an easy question with 6 minutes left? That's a good one, right?
Yeah, I'll just predict what's going to
Yeah,
happen. 10
Please
years
predict the
from now,
future.
because
Yeah,
that's,
there are
you
only
know,
a few people on the call, Mark. So if you got lottery numbers, just throw them out and we'll
there'll be 2 more pandemics.
it's just between
and,
us. Yeah. Oh no. Oh God.
So I think the future of mass timber is very, very bright. I think when we look at the sustainability aspect of it is obviously a big key to it. And then the growth of it in general is going to bring more manufacturing. It's going to bring hopefully more competition in the market. And I think the big change is the building code. You know, the building code has been playing catch up ever since mass timber was introduced in the United States. 2015 was the first code that referenced across laminated timber. The 2021 code was the first code that let us go beyond what we could do in light frame construction. Up until then, we were sort of saddled with this 85-foot maximum. And so now jurisdictions that adopt the IBC 2021 can go up to potentially 18 stories. That's fully encapsulated, 12 stories partially encapsulated, and 9 stories fully exposed. That's changing though. The IBC 2024, we already know that it's going to have more exposed wood allowed in projects up to 12 stories. And the city of Dallas has already adopted that. And I know that I have spoken with developers that have asked about what other jurisdictions might be willing to allow the increased exposure amount in type 4B construction, which is in essence 100% exposure. I think we have projects like the Ascent project in Milwaukee, which is a 25-story mass timber building, 19 stories of mass timber on a 6-story concrete podium. And even though in the IBC 2021, we're not allowed to expose any mass timber at 18 stories, that project has about 50% exposed mass timber in the 19 stories. And I think there's been some additional fire tests that have obviously proven that as a safe system. So I think as the building codes continue to evolve, I think we'll see increased opportunities where mass timber can go head to head versus other systems. And with that type of potential growth, we're just going to see a continued increase in the material and a continued increase in the manufacturing of it.
And I appreciate the link, Bill, here. Are we going to run out of forests? I mean, that's kind of what I was getting at when I asked the question, kind of to put it simply. I tried to ask with smarter words, but that's really what we're getting at, right? So
yeah. And the answer is this study. I encourage y'all to look at it. I mean, it's basically the North American forest. Could we support the growth we're going to see in mass timber, like Mark's saying? We were seeing this kind of hockey stick, but we're really building, 5-6 million square feet a year right now, which is a drop in the bucket in the multifamily commercial institutional world. So basically this projects what we really will be doing by 2030, and then how many trees are going to grow. So you can kind of see the difference in the forest growth harvest bar, not harvest everything, just the same rates that we're doing today. We'll be able to sustain what's happening with the mass timber growth, because it feels like it's everywhere, but it's not in the scale of there's actually 17,000 projects built every year that by code could be wood that are not. So we have thousands of projects that we can do. And we're not saying we're going to do all 17,000, obviously, in a year and next 10 years. But, as we grow this, we can sustain it. So I'll leave it there. I've been talking a lot. Adam, I think you were going to.
Yeah, I was going to say on the positive side, it probably leads to the preservation of more forest land, right? Because, these forests, you have to grow these trees for 40 something years, right, before you harvest them. So during that time, that forest is there and it's growing before it gets harvested. One of the things we saw that was really interesting in Oregon was they had some recent wildfires, and they were harvesting the wood from the wildfires. The outside of the tree burned, but the wood on the inside was still good, and so you could still make 2x4s out of it and glue it up into mass timber. I think also some of the knowledge from the manufacturing process is that this manufacturing isn't foreign. It's glulam manufacturing essentially when you're looking at CLT, and so it's just an extension of the mass of the timber operations that are already there in making 2x product. So yeah, I think you're going to see it grow exactly like Mark said. It's going to be hopefully it's going to be a huge part of the market in the future going forward.
All right. 1 minute early if we ended here, which is fantastic. Obviously we can keep the conversation going. We'll post this online on our YouTube channel and kind of link to it. And hopefully we get a ton of views on it. I don't know. It's a huge topic. Thank you to the small amount of guests. As I said, who were here. We usually see more. I don't know why, because mass timber is awesome. But this has been great and super educational, and I really appreciate all the links. I've screenshotted them, and I'm ready to go again. As someone who does a ton of LCAs, I want to be up on it. So thanks, folks. Great conversation, and I'm gonna jump out of here, and you hear more from us, and then CLF Austin, we will be in touch with the next round of things near the end of this year, and we'll get geared up for another year of presentations and bringing folks together. So appreciate
Sounds
everyone
good.
jumping
Thanks,
in.
Tom.
Yeah,
Thank
thank you
you.
so much.
See you all.
Thanks,
Thanks,
folks. See you
everybody.
later. Bye bye.